Hello everyone, so in this problem we're going to calculate the length of this curve. This curve is f of x and it is defined as x squared divided by 2. So we see that the derivative of f of x will be just x. Now how do we calculate the length of this function? It is just square root of 1 plus the square of y prime times dx with x from 0 to 1 because, well, we're calculating the length from x from 0 to 1. This is because the length of this, function can be calculated using Pythagorean formula. We have a small amount of x, say delta x, and we have a small amount of y, say delta y. So these two are perpendicular to each other, and the third side is the, length of this formula. So there you go. You just use the Pythagorean formula to come up with this relationship. So anyways, now we have this formula. Well, y prime is just x, so this integral becomes the integral of square root of 1 plus x squared times dx with x from 0 to 1. Now, square root of 1 plus x squared would be quite difficult to deal with, so how about let's change some variables? We want to get rid of this square root, so you can think of, how about let's change x to tangent of theta, because 1 plus tangent squared theta is equivalent to secant squared theta. And in that case, we can reduce this secant squared theta with our square root, so it becomes secant theta. So anyways, x now equals to tangent theta, so dx will be equivalent to secant squared theta, d theta. So let's substitute these into our equation. X is from 0 to 1, so when x equals to 0, theta will be equivalent to 0, and then when x equals to 1, theta will be equivalent to pi over 4. So substituting all these informations into our original integral, we get the integral of square root secant squared theta times secant squared theta times d theta. So this integral becomes secant to the third theta times d theta with theta from 0 to pi over 4. Now this integral is actually quite difficult to tackle. The best way is to use the integration by parts technique. So integration by parts technique is to pick the part that is easier to do differentiation on as a u, and another part that is easier to do integration on as our dv. So in that case, secant squared theta d theta is just the derivative of tangent theta. So how about let's pick that as our dv. So secant squared theta d theta is our dv, so v is tangent theta. And on the other hand, secant theta is our u, so du would be just secant theta times tangent theta times d theta. So integration by parts works like this. If you have something in the form of u times dv, it is equivalent to u times v minus v times du. So now we have u as secant theta, v as tangent theta. We can put that in our formula. We get secant theta times tangent theta with theta from 0 to pi over 4 minus the integral of v times du. V is tangent theta, and du is secant theta times tangent theta times d theta. So this integral becomes, the integral of secant theta times square of tangent theta times d theta with theta from 0 to pi over 4. Now notice that we can substitute tangent squared theta with secant squared theta minus 1. So that is what we're going to do right here. And as a result, we will get this formula. This is, the first term, square root of 2 is just the integral of secant theta tangent theta with theta from 0 to pi over 4. And we can expand the second term of this integral so it becomes two terms. The first term is the integral of secant to the third theta times d theta. And the other term would be the integral of secant theta times d theta. So now notice that this formula is actually equivalent to the integral of secant to the third theta d theta. So as a result, we can see that there's got to be a relationship between the integral of secant to the third theta times d theta and the other terms, which are square root of 2 and the integral of secant theta times d theta with theta from 0 to pi over 4. So first of all, let's calculate the value of the integral of secant theta d theta with theta from 0 to pi over 4. If you remember it, it is just natural log of the absolute value of secant theta plus tangent theta, and theta is from 0 to pi over 4. So the value of this would be natural log of 1 plus square root of 2. So there we have it. The integral of secant to the third theta d theta will be equivalent to square root of 2 minus the integral of secant to the third theta d theta plus natural log of 1 plus square root of 2. So we can see that the integral of secant to the third theta d theta is equivalent to square root of 2 plus natural log of 1 plus square root of 2. So we can see that the original integral, which is the integral of second to the third theta times d theta, with theta from 0 to pi over 4, will be equivalent to 1/2 of square root of 2 plus natural log of 1 plus square root of 2.